Worksheet 1. This is review. You did circles, possibly in Algebra 1, definitely in Geometry, probably definitely in Algebra 2. So, quick review. New packet, circles. Got it? Okay. The faster we get through this, the faster we get to questions for tomorrow's homework check and the opportunity to talk about tomorrow's quiz. Tomorrow's quiz is only 25 points, okay? But there's only 10 little questions on this notes worksheet, so let's go. All right. Eventually, we're going to talk about a word called locus. Locus of points simply means all the points that satisfy a condition. And the locus of points for a circle would be the condition satisfied is all points the same distance from a center. What is that distance called? The radius, right? The same distance from the center, they're all that radius away from the center. Okay? In a plane, if it wasn't in a plane, it would be a sphere, blah, blah, blah. Okay. Anybody think this looks familiar? This is the distance formula, yes? So the distance from that center out to the edge is really the radius. Now, if we want to get rid of this, we do what to the other side? That's the equation of a circle. Does it just make a big connection in your brain? Okay, the distance formula is really the equation of a circle and the other way around. So when we have something like this, we use h instead of two different x's, okay? We use x minus h. This is standard form of a circle. So you should be writing this on your notes where it says standard form of a circle. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So what is the center? HK. So it is the opposite of each of those, right? And then the radius is just r. So make sure you realize that this is actually the radius squared. Somehow that escapes some students later. Okay. Now we have a little warm-up activity. This site, guys, this desmos.com is a great graphing calculator to use, but it's fantastic for this chapter that we're starting because all of the equations in this chapter are really, really hard to solve for y equals. So therefore, they're really hard to graph in our calculator. Do you know what I'm talking about? Because you have to put everything in y equals form, okay? So if we go to this site, this calculator, you don't have to put things in y equals. Look at how I could type these in here. So you can type things in without them being in y equals form, all right? And it'll graph. I want you to predict what this, I'm gonna move this over a little bit. Okay, predict what this first equation is gonna look like. Center at 0, 0, radius of 4, okay? So there's center at 0, 0, radius of 4. What's the difference with this next equation? Okay, so it's going to be at the same spot, but smaller. There you go. What do you think about this? Be careful. Think hard before you say anything. The center is going to be at 0, 2, so it's actually going to go up to. Everybody okay with that? And the radius is different. Yes. Okay. What about this fourth one? Okay, 4, -2, and it's the same size as which circle we already did? The very first one, okay? So it's taking that red one and moving it 4 to the right and down 2, okay? Now, this is actually a preview of something to come, all right? When we stretch, remember multiplying is a stretch? If we stretch this one way and not the other, it becomes an oval, which the word is called an ellipse. And that's about 2 or 3 lessons from now, which actually isn't until next week because we got a quiz and all kinds of stuff. A weekend, thank goodness, right? All right. so we're going to get to ellipses in this chapter. All right, going back to the notes, couple quick things. You already wrote this first one down, yes? Standard form, everybody got that? All right. What is the area formula for a circle? Okay, the area and the circumference formula both have a 2 and a pi and an r. Okay, they both have a 2 and a pi and an r. Then the question is, area is what kind of units? Square units. So that one has the r is squared. Circumference or perimeter of a circle, distance around the outside, is not square units. So it's just 2 times pi times r. You will learn in, or diameter times pi, exactly. That's the way I remembered it too. But you will learn in calculus that this is the derivative of this. Oh, it'll be a wonderful moment when you get there. Okay. Number 2. So tell me what we know about this so we can graph it fast. 2, -3. Okay. And the radius is the square root of 4 or 2. Now we're going to do the sketch. Now, you can only go up, down, left, and right, because if you go out at an angle, 2 units is not going to land on an ordered pair, right? Okay. So mine kind of looks like a deflated football or something, basketball, I don't know. It's a little dented. We good? All right. I don't know why, but this one always stumps students. I get some crazy business. Where is the center? Okay, -1, 0. And the radius is 6. So this will be just an amusing experience trying to get me. I'll freehand it just to make it funny, okay? Because I'm pretty sure my free-handed circle that big is going to be awful. Oh, yeah. There you go. Yes, right here. It goes through that ordered pair clearly. All right. I cheated and used the circle tool earlier, and they said I shouldn't do that. So they have to draw a bad circle. I have to draw a bad circle, right? All right. So standard form is what we just practiced. Can someone stick this information in and come up with standard form? Basma, what you got? Okay. Okay. Be careful, because sometimes we get 9 or 3, or it's radius squared, so it is 81. Everybody all right? All right. The next kind can be a stumper on a test or quiz for a lot of students. Okay. The center is given, so that shouldn't be tricky. This is H and this is K. How would you find the radius? Okay, that's what I would do as well, because this one lines up, yes? If you go to the left 15 and up 3, or you go to the left 15 and down 1, from +3 to -1 is just a distance of 4. But what if they didn't line up horizontally or vertically? Yeah, you could use, to find the radius, you could use the distance formula, yes? Okay. So I'm just saying that, yeah, just so you know how you could do it if they didn't line up. All right. So this would come out square root of 16, which is 4. That's the radius. Now what's the formula look like, or the equation of the circle, guys? (16), right? Because radius squared, everybody all right? All right. Now we're going to talk about general conic form, and you're never going to have to do this. In this direction, you're going to have to do it backwards. I want to do it once in this direction because it will tie and remind you of why it works in the other direction. I'll explain that in a second. Right now, would you just write down maybe general conic form ax squared plus by squared plus cx plus dy plus e. So when you just FOIL it all out and you get a disaster. Yeah, there's just a bunch of letters. If we do these in 3 dimensions, there can be an xy term in there too. We're not going there. All right. So can you start with standard form for me? Who can do this one quick? Jared, just tell me what this would look like. X. Okay. Standard form. Now we have to get it into this crazy conic form. I promise we're not going to do this very often. I just want to talk about how this happens. When you do x minus 7 times x minus 7, you get what? Okay, we just squared that. Okay, we're going to do it backwards in a minute and complete the square. But do you see it was 14 in the middle, even though it was minus 7 and minus 7, right? Okay, over here, y minus 1 times y minus 1, y squared. Okay. It's supposed to equal 0, so I'm going to go ahead and do minus 16 over to that side. Is that okay? I guess. Okay. Now I'm going to rearrange it in this crazy order. X squared plus y squared minus 14x minus 2y plus what? 49 plus 1 minus 16. Okay. Is it okay if I don't put that on the next quiz? All right. You want that on the quiz? Okay. The quiz tomorrow, you want 12 of those, right? All right. They're not that bad. They're just miserable algebra manipulation. I only did that problem because you have to be able to do it this direction. Oh, this is easier in my opinion because we're going to practice and it's going to be fast. We're going to put the x squared and the x's together. So we're just rearranging now. And we're going to put a blank. Remember good old completing the square? Okay. Then we're going to go plus y squared minus 2y plus blank equals, I'm going to move this guy over the other side, so he'll become what? Negative 222, and I'm going to be all fancy and put plus a red blank plus a green blank. Okay. Okay, do you remember how completing the square works? You take half of this, so we'll have x plus 15. Remember, we're trying to get this in standard form by completing the square? And then you square that. Okay. Do you remember? Because a minute ago it was minus 7x became minus 14. It was twice as much, so now we have to half it. Is it kind of tying together where this is coming from? All right. Plus y, and we do half again. So it's minus 1, yes. And then we square it. I don't know if that says squared. I can't with my bifocals even see what I wrote. Square it, and we get positive 1, yes? Oh, wait a minute. Whatever we put in the red on this side, we got to put in the red on this side. Whatever we put in the green, we got to put in the green on this side. Okay. Equals negative 222 plus 225 is 3, plus 1 more is 4. Is that standard form? Yes. It's really not hard, guys. It's going to get harder when we have ellipses and hyperbolas because there's going to be stretches, and then we got to, it's okay. For now, all we got to do is complete the square. Tell me the two things it asked for. The center is also at, and the radius is 2. Okay. I want you to try number 8. I'm going to give you a full 60 seconds to try number 8. What you need? 256. Miss Newnham, is that how you say her name? I always say it wrong. Newnham? Yes? Oh, no, that's her room too. But Mr. Johnson teaches in there once or twice a day. I think so. Anyway, okay, guys, what did you get here? 15 and 225. Everybody okay on that one? And what did you have back here? Minus 16 and 256 equals, is it 5? Okay, so, because we added all this together, is that not what you got? Did everybody else get 5? Okay, center. And the radius would be an ugly square root of 5, which is a little over 2, right? All right. Any questions? All right. This one looks tricky, but it's not really that bad. It's only a circle, yes, if everything, the x squared and y squared don't have a coefficient. So let's just divide everything by 4. Yeah, but that's okay. We'll just deal with it. It'll cancel out in the end. 4x squared divided by 4 is an x squared. Ooh, can't write. Plus, what are the x's? Ooh, minus. X squared minus 96 divided by 4. 24x. I'm going to put a plus blank. Maybe. Then the y squareds. 4y squared divided by 4 is just a y squared. Negative 12y divided by 4b, negative 3y plus a blank. And then I'm going to move this guy over the other side. So it's negative 441, but he is divided by 4, right? You can put a decimal, doesn't matter. I'm going to deal with it later. All right. So the first one with the x's, who's got this one? Plus? Now, you can do a decimal here because the worst it's ever going to be probably is a 0.5. But I'm going to leave it 3 over 2. Is that going to freak anybody out? When you square it, square the top, square the bottom, and you get 9 over 4. Because it's okay to just type this in all at once if you type it correctly. You don't need parentheses or anything. Negative 441 plus, or divided by 4. I can't even say it right. Plus 144 plus 9 divided by 4. Did someone else get that nice round number? All right, so last one, center. You can write 1.5 or 3 over 2, anything that's equivalent. And the radius. All right, we good? All right. No, I lied. All right. This is a great question. This will definitely show up somewhere because it makes you think. If these are the ends of the diameter, where's the center? At their midpoint. Oh my goodness. Do we remember how to do the midpoint? Add and divide by 2. Add and divide by 2 because we're finding the middle of two numbers. We get what? Everybody okay? Now, we have an option. We can do the distance from here to here, and that'll be the diameter, which we got to then remember to cut in half. And then when we put it in the formula, we got to remember to square it, which is fine. I like to just pick one of these and this because the distance from one of those to the center is the radius. Then I won't have to cut it in half. Yeah, if you got the center wrong, you're going to be messed up on the end anyway. But the thing is, once you do the radius, you don't even have to square it because the radius is the distance, right? And really, we need radius squared in the end anyway. All right, I want to talk you through this because I hate the distance formula. How far is it from 0 to -6? How far is it from -2 to +1? So that's all I ever do is I do them in my head. This is 36 plus 9 is square root of 45, and that's r. I'm not going to find out what that is because when I put it in the formula, I'm going to do what? R squared anyway, yep. So it's going to be x plus 6 squared plus y minus 1. Remember, this was our center over here. Squared equals r squared, which is just 45. Okay. All right. I have a couple more examples on this before we start talking about other stuff. You don't have these, so please don't look for them. But there's a question on your homework that says, given the area, write the equation. If this is the area, do you really know the radius? Okay, you could do one like that. What if it said given the circumference? This is 2 pi r, so if you cancel out the pi, 2r is 6, so r is 3, and then you could write the equation. That seem okay? These are a struggle for me. It's translate this circle 1 to the right. This is what I have to do. I have to write, okay, the center is at 16, 4. That means I'm going 16 to the right and up 4. If I go one more to the right, this would be a 17. So now I can go back and write the equation. Okay, I have to do it that way because otherwise I'll mess it up. But you can do it whichever way you want, but it wants you to move it all to the right one. Does that seem okay? You could handle that? There's one of those on the homework. You don't have this particular example. All right. I am switching over to talk about questions you have and or look at what's on the quiz. What do you want me to do? Worksheet 9. Okay, worksheet 9 is the joking something, yes? You have to do 5 on one side. Are we on the right worksheet? And 3 on the other side? And which side did you want me to do? Side B, number? Really? We can do this. You have to get a common denominator. Do you only have to do 3 on this side, guys? I think I did 1, 2, and 3. I would if I were you. You can do that one, and I could do it if you want. I'm just thinking that how would you do, let's do 1 on this side just so you feel a little bit better. Let's do 2 or 3. Which one do you want to do, 2 or 3? 2? Okay. So we're going to expand this out, the top. You can change it to X's and Y's or A's and B's if you don't like these goofy symbols, okay? I need my blue sheet. Okay, the sign is sine of alpha cosine beta plus cosine of alpha sine of beta. And that's all over this denominator. Okay, now what? Okay, separate it. Some of you have done this. If you rewrite it, you can't cancel right now, right? Because you'll kill kitties. But if you rewrite it as 2 separate pieces on the top, I'm not leaving this up here, Tysier. You might want to wake up. Those are supposed to be alphas. If they're looking really bad, you can change them to A's and B's. Sorry. All right, I think I wrote that correctly. Well, look what happens. What's all this on the left? All this cancels and we get 1. And then if we take the 2 that have an alpha and put them together, because this is all multiplication, right? And we take the 2 that have a beta and put them together. Wow, what do we get? Yes, no? Okay, I think if you try 1 and 3 on this side, you'll be okay. Who else has a question? Emma. 10B number 4. $10B number 4. This is a good quiz question, guys. This could definitely be a quiz question. Okay? Can you find something on your blue sheet that says 1 minus 2 sine squared of gobbledygook? Like an A or a theta or 1 minus 2 sine squared of theta is equal to what according to your blue sheet? Okay. Double angle. And remember I told you on the quiz it's all about familiarity with the blue sheet. Can you find stuff on the blue sheet? Okay. So what are we going to trade this out for? Instead of a theta, we have a, so it'll be cosine of 2 times 6x, which is better, Emma? Now you know what kind of question it's talking about. They weren't all the same on this section, I know. Number 3 is that kind of question. Did you do that one? Okay, number 3, this is a 2 sine theta cosine theta. Anybody find that one? Yeah, it is the sine of 2 theta, so this will be the sine of 2 4x's or 8x. Everybody feel better about that section? This is also on the quiz, but it starts out on the quiz. It says, what is equivalent to and it says like cosine of pi minus x. So the first thing you would do is expand it using the sum and difference formula, and then you'd flip your blue sheet over and replace cosine of pi with what? -1. And the sine of pi is 0. So what is that all going to simplify down to? I think that particular question is a multiple choice question on the quiz. It might say sine of x, negative sine of x, cosine of x, negative cosine of x, and you got to pick the right equivalent. All right, so those were good questions to review some quiz concepts. What else? Number 5 on this one? Okay. There is simplify or prove questions on there. I don't think there's one exactly like this. It's not written well to begin with. There's extra parentheses up here. But how would you square the top? It says cosine x plus sine x. That is supposed to be squared. Can I write it out like that so you can FOIL it? So what's going to happen up top there? Cosine times cosine is cosine squared. Okay. What's one of these and one of these? Yeah, there's 2 of those that are a cosine times a sine, or a sine times a cosine, whatever order you want to write it in. And then there's a sine times a sine, which is a sine squared. And there was a -1 on the back outside of all that. Now what? The 1's cancel out. Where's another 1? Okay, cosine squared plus sine squared is a 1. You don't have to write this all out. You probably don't have room. I'm just trying to make sure the audience at home can follow it. How's that? The 1 and the -1, that's 0. So now we're left with 2 cosine x sine x over, is there a trade for sine of 2x? Oh, it's 2 times the sine times the cosine. Does it matter that I have the order? No. If they're all multiplying, as long as there's no glue, right? No adding and subtracting. Yeah, you could switch the top to cosine or to sine of 2x. Yeah, absolutely. It all cancels and we get 1. Nine A number 7. 9A number 7. Okay. Can I trade something for the denominator down here? What is 1 minus tangent squared? Nothing. It is nothing. Okay. Yeah, you don't have to do this. You only have to do 5 on this side. So, we could do sine squared over cosine squared. I'm just trying to figure out if there's something. You know what? Let me think about this for a minute. If I make this numerator, I just leave the numerator, okay? It's being divided by 1 minus sine squared over cosine squared. Okay, what if just in this parenthesis I get a common denominator? This would become cosine squared over cosine squared, right? So then what would I have? Cosine squared minus sine squared, I'm still copying that parenthesis down, is being divided by, when I combine those, I have a cosine squared minus sine squared on the top. Now, I lost a theta, oh well, all over the common denominator, which was just a cosine squared, and then you do what? Yep. That's times the reciprocal of this mess. Most of you would not have done that one, I'm thinking. Well, since the theta is missing, I'm gonna... So all of that... Now I did one on that side for you. Yeah, I probably wouldn't have picked that one to do, but if I only had to do 5. All right, can I go to worksheet 10 again and talk about equation solving, because that is on the quiz? Unless someone's got another question. All right, you do need to be able to do some equation solving, like, well, let's say number 1 on side A. What can we do here? Take out a cosine of x, what will it say then? 2 sine x minus square root of 3 equals 0. Are you okay from there? Cosine is 0, or can I skip down to this part? Square root of 3 over 2. If I subtract that, set it equal to 0. Did I skip too many steps? All solutions. Yep. Where's the cosine 0? That's fine. That is equivalent. Where is the sine square root of 3 over 2? Pi over 3 and 2 pi over 3. Yep. Okay. And if it didn't say all solutions, we wouldn't need all those plus or minus things on the back, right? If it just said 0 to 2 pi, we would have just had 4 answers without any pluses or minuses. All right. So on the quiz, problem number 1 says prove the identity. Oh, then I'll stop reading. Number 2 says simplify, and it's like one we just talked about. Okay. There are 2 that say solve this equation. Okay. There are some that you just have to simplify like we did here, particularly like this number 4, okay? And then there's a prove and another simplify. There are 2 more kinds of questions on here. 2 more kinds, 3 total questions. There's only 10 questions on the whole quiz. 1 is a Ferris wheel question. Remember the Peach worksheet? Okay, write the equation and graph it and use the equation to find the height at some strange time on his ride. Okay, need me to make up one of those? We can. The other kind of question is something like this. There's 2 of them. It says maybe the cosine of x is negative 3/5 and x is in quadrant 2. And then it says find the sine of 2x. What would you do for that? Okay, draw it in quadrant 2. Cosine is adjacent over hypotenuse. You do Pythagorean theorem. This is a positive 4. Then you go to your blue sheet. And it says 2 times the sine times the cosine, yes? And it says find the exact value, by the way. of this. Could I make this a little more confusing? All right, so you'd have 2 times the sine from this picture times the cosine from this picture, and your answer would just be negative 24 over 25, maybe? Okay. I think I'm on 10. Is everybody okay with a question like this? Okay. 10A, what number? This one? Okay. This is a great question because I think I did it using a U substitution. There's nothing nice here except, can you find that one, guys? Find that on your blue sheets. Oh, you could, if you, no. Okay. Claire found this on the blue sheet. She said it's cosine of 2x. Do you remember how much fun with these we had with these when there's a 2 in here? We had to do a U substitution. It's not on the quiz, but let's do this one together. Where is the cosine square root of 3 over 2? Answer me. Where is the cosine square root of 3 over 2? Now, if that's U, what did I substitute U for? 2x. No, it's not on the quiz. There's not a U substitution question on the quiz. So if I replace U with a 2x, what do I have to do to these answers to find x? Yeah, I have to find half of all that. What's half of a pi over 6? Pi over 12, and half of a 2 pi n is a pi n. Half of 11 pi over 6 would be yes. Yep. Let me go over that. I got 30 seconds. I'm going to go back to this question I was just doing a second ago that I made up. Okay, what if instead of finding the sine of 2 theta, it had said find the cosine of x over 2? You go to this sheet and it says plus or minus the square root of 1 plus the cosine divided by 2. You have to decide plus or minus. If I'm in quadrant 2 and I cut an angle size in half, it's going to end up in quadrant 1. And a quadrant 1 angle's cosine would always be positive. Okay? If it was, say, in quadrant 4 originally, you'd say, well, I'm between 270 and 360. If I cut those in half, I get 135 and 180, which is quadrant 2. And cosine in quadrant 2 is negative. Okay? You really have to think about what you're cutting in half. If you want more practice on any of this, day after tonight or coming in the morning, it's a 25-point quiz and you have a homework check due.